A very warm good morning and very hearty welcome to Intuit India's Hacktoberfest Meetup 2024. I'm Ritvika, software engineer too with Doc Comprehension Extraction, IDXBU, and community lead for Open Source India uh, Intuit chapter. You know that feeling you get when you walk into that favorite coffee shop and that smell hits you, and you exactly know that it's going to be a good day? That's how I feel looking at all of you right now. Once again, welcome to Intuit's Hacktoberfest Meetup 2024. Last year was the time we had an event with an external audience. So it feels great that we have been able to follow last year's success with this year's external meetup. This year, we knew that we had to level up, turn up the volume, and bring you some more of the open source goodness. I'm not going to lie. If you see, I stuck the speaker lineup. And let me tell you, we have got seriously brilliant minds about to grace the stage. They are going to be talking about everything from the latest trends in open source to the challenges, emerging industry needs, trends, standards, and opportunities that lie ahead in open source. And I see all of you have found coffee, snagged some sweet stack, and let's get started. To fully appreciate this incredible month long celebration, let's take a trip down memory lane and see how just far open source has come. If we start from 1980s, we got GNU Manifesto, GNU GPL license, which created a foundation for even more and collaborative software world. The seeds were sown with inventions that changed everything when in 1990s, the first public release of Linux kernel, the birth of programming languages, these innovations transformed how software was built and shared. Around 2000s, the first release of Linux was Ubuntu made Linux accessible to everyone. Mozilla Firefox challenged the browser giants. Git revolutionized version control, and Android redefined what a mobile operating system could be. Around 2010s, we got GitLab, Google Chrome, which was based on Chromium, and also that rose to dominance. Docker and Kubernetes reshaped how we build and deploy our applications. Tools like VS Code, TensorFlow, and countless others become indispensable. Around 2013, the pivotal moment. That is, the very first Hacktoberfest happened, and all thanks to DigitalOcean, the annual celebration of open source began, inspiring countless contributions. Around 2018, the first world shifted as Microsoft acquired GitHub, a testament to the undeniable power and influence of open source. 2020s, open source continues to flourish. We have seen the emergence of groundbreaking tools like Backstage, Open Telemetry, Open Lineage, and of course, the era of AI took off with OpenAI's GPT and LLMs, all powered by open source collaboration. So we here meet today for open source and Hacktoberfest. And why exactly we do it? We know it's a month-long celebration of open source, of something which we all are passionate about, and we meet every October. So how it works, some of you may be maintainers, some of you may be the contributors to the open source world, and we again welcome you heartily. And why exactly we contribute? We contribute for the deep satisfaction, the passion that we have for open source, the career that it gives you a personal brand and credibility by building an open public portfolio via OSS. Networking, you meet awesome people, say to network with like-minded open sourcers and kickstart the great opportunity to get started and rekindle OSS. Now I could stand up here and talk about how amazing open source is. But I know you are all here for the real deal, the OGs, the experts, the open source ninjas here. So without further ado, I'm going to hand the stage over to someone who is equally passionate about the open source world. Please give a warm welcome to Aditya.
Awesome. Thanks for the kickoff, Ritvika. And thanks for walking us through how open source has evolved over the decades. It's great to see a lot of you have made it up here despite Bangalore traffic and added to it the rains. So my name is Aditya. I'm part of the Intuit India A2D org, the AI data analytics. I joined in 2019 for a lot of reasons related to open source, as what kickstarted my career, and I've been leading the open source community since then in Intuit India. And today we have a huge list of speakers, and we're really excited to have you all here. Without further ado, let me first introduce the first speaker of the day. Are you all excited? Awesome. Cool. Join me in inviting Ravi Hari. He's our first speaker. So Ravi Hari is from Intuit. He's a principal engineer with the Observability platform. Prior to Observability, he has also worked on the Intuit Kubernetes services. It's basically a platform around how microservices can run on top of Kubernetes. So he has also presented a lot of KubeCons and ArgoCons and so on. So please join me in inviting Ravi Hari. Yep.
Welcome everyone. Good morning. Let me walk through uh, some of the challenges that we had with open source projects that we use in observability space, and let me walk through why observability is leveraging open source quite heavily in Intuit, and how we can consume open source and how we can contribute back. That's primarily the agenda I'm going to walk through, and hopefully I can inspire a little bit contributing back, right? So, what is observability, right? It basically refers to understanding the internal state of the system by looking at some external outputs that we are receiving from that system, right? And there are various data points or telemetry data that we can get out of the system, but how we measure observability is by looking at these numbers. If there is a problem, how fast we are able to identify or detect the problem, and how fast we're able to recover from that problem, and how fast we're able to identify exactly what is the problem so that we can recover from the problem. So these are our uh, measurements on how well we are doing on observability, right? So in order to achieve this, we can kind of look at what all can contribute that can help achieve these goals for us, right? So there are various pillars in observability, like metrics, which primarily provide numerical measurements on the system states, such as latency, usage of resources, and so on. This can help us identify the problem, like detect what is going wrong. And then logs, they are kind of chronological order of events that are going through in our system. This can help in both detect the problem as well as recover from it, and once we make the fix and review it from the logs. Traces help connect end-to-end flow of requests going through a distributed systems. So this can really help in identifying the problem, the MTTI part of it, and it will also help us discover the potential services that are problematic, and which we can go and further look into what is going wrong. Profiles are captures of a program that connect to the code base. Once we know which service is a problem, then we can look into what calls have been a problem in that with traces, and then connect that to profiles and look into which lines of code are contributing to that problem, right? And then finally, we have events. Events are kind of again, they can be chronological, etc., but there are significant changes in the system that can impact the state of the system, be it performance, or be it change in the system restarts, etc., and so on, right? So all these are different pillars of observability, and we have many projects in each dimension for each pillar of observability. And then what is the advantage of leveraging open source, right? One, we are not constrained in any ways. We can pick up the code and make it flexible to the needs that, in our system, and customize that to whatever extent that we want. And we can contribute back and see if many other companies are also looking for such a pattern by getting some feedback from the community. And then uh, unlike commercial vendors and all, open source is very cost effective, and most of it is something that you can control by adapting it to your needs. And then, yeah, as I said, community support is is there for the open source projects, and there are bunch of Slack channels you can reach out to, or you can post a message in the issues or threads, etc., that you can create in the projects, and you can get a lot of support there. One other thing is, a lot of these open source projects which are actively used and which are actively getting contributed to, They also have to abide by some security standards if they are, say, associated with one of the organizations such as CNCF or Apache, etc. So security is inbuilt in these projects, and all the CVEs, etc., are taken care and addressed as soon as possible. So we can leverage all these benefits from the open source projects and use them in our respective space, right? So these are some of the projects in the CNCF landscape today that are available. And as you can see, I'm highlighting the critical projects from the observability space here, like Prometheus, Eager, and Fluentd, which are used for multiple pillars of observability. And there are some projects that are incubating, such as Cortex, Thanos, OpenTelemetry, and so on. So I'm going to walk through some use cases for which at Intuit we found the need to contribute into the open source as well as consume it for a lot of use cases that we adopt to, right? So the first one that I'm going to talk about is notifications in Argo alerts. So we at Intuit use Argo alerts for blue, green, and primary canary deployments. And one of the things that we wanted to know was as we do the canary deployments, we wanted to get alerted or notified on various states the rollout is in progress with. For example, it could be a rollout pause state or updated state or analysis done successful or failure and so on. We would like to get update on various steps that we put in the rollout object, right? Uh, but if you see how the default notifications are subscribed to, you'll see that a lot of these things are repetitive. For example, the Slack channel that my team uses may be the same channel, but for everything I had to punch in that Slack channel with the corresponding condition. There is no easy way available at that time for us to subscribe on multiple things as a list and subscribe to a single channel, right? So that was one use case, and the change when was made, and we were able to contribute to that, and this is a contribution that we had. Now, as you can see here, we could make it a subscription list, and for a lot of these conditions, we could get notified into a single destinations or multiple destinations as required, right? So uh, this has made notifications very simple for us, and we we later enhanced it to have PagerDuty and other integrations so that we could get alerted for an incident and so on. So this is the first use case. But beyond this, there are a number of other issues that we have identified. For example, we had to punch in Prometheus endpoint in every analysis template that we wanted, right? But that was too much overkill on the developer side to write that Prometheus endpoint in all the analysis templates. So we had to make it an environment variable in the rollout deployment in itself, so that teams can directly refer to that in the analysis template, don't have to necessarily type in all those details, right? And there are various other bugs that we found in the rollouts that we were able to fix, right? And one such thing I just want to call out is your contribution need not always be code. It can also be documentation. For example, rollouts was never tried out with VPA. One of the contributions here, as you can see, is how can we leverage Argo rollouts in if we leverage vertical pod auto scaling and so on, right? So there are a bunch of steps that are required for it, and all those things, once they're documented, a lot of other companies have started adopting rollouts with PPA and so on, right? So yeah, these are some examples on the Argo rollout side, right? This is like one use case. The next use case I wanted to talk about is on uh, capacity issues. How did we remediate for the capacity issues using Active Monitor? A brief overview, Active Monitor is like a controller in Kubernetes or an add-on Kubernetes that launches Argo workflows based on the custom resources that we submit and checks for the health, either by connecting to the cloud providers or to the Kubernetes resources or an endpoint like Prometheus and so on. And it can publish metrics based on the usage or based on the work that it had done, whether write metrics on the capacity usage on the cloud providers, such as a number of ALBs or number of IP usages on the Elastic IPs and so on, right? But once we hit the limit, there are also APIs these cloud providers provide for us to extend the limits so that it doesn't become an incident for us, right? That was not available out of the box in Active Monitor, so we had to extend that. Briefly, the extension is to introduce the remediation workflow along with the health check workflow that we have, so that as we submit the CR, by default, it executes the health check workflow, and as long as there is no issue, at a specific interval of time, it keeps on executing that. But when there is an issue that it exceeded or breached the threshold, we could directly go ahead and execute the remedy workflow and then rerun the health check back, right? So that way, every periodical interval, we are ensuring the health check is successful by keeping, as long as the limits are under control. But at any point in time, if it breaches, we can execute this remediation workflows. Uh, Again, there are a bunch of other issues also that we have identified, and we can see some contributions that we have made into this project and so on, right? Yeah, the other use case I'd like to talk about is on time series databases. So as a standard, as I have shown you, CNCF projects for metrics like Prometheus and Thanos are the standard ones. We kind of adopted Prometheus and Thanos at Intuit widely across 350 plus clusters, and we have solved various use cases with it. Briefly, the setup is like we had Prometheus reading data from services. As you can see, services are pods on the right-hand side. And we were able to consume the data and write it to different endpoints. We saw that a lot of use cases are growing. For example, we wanted to show the critical golden signal metrics on the Argo CD UI, and we wanted to also leverage these metrics for AIOps use cases using NumaFlow, where the NumaFlow generates inferences and kind of leverages it again in the Argo rollouts. Using the anomaly detection, we wanted to either roll forward or roll back based on different conditions, right? But some of the challenges that we faced here are the query layer or the read path of Thanos was not scaling in the clusters where the number of metrics are in the order of 10 million plus, right? So what we saw was, even though a new pod gets added, we can see the graph line for the bottom one, the pod came up, but for it to take traffic, it took almost an hour, right? And because of which the other pods, they are going into a crash flow back off and so on. So this was not helping us. So this is one use case. In this case, what we had to do was either we could go back and contribute into Thanos or look at what are the other alternatives available. What we saw was there is a lot of work going around in this space, and a lot of new technologies have emerged out of this. And based on our evaluation, we found Mimir to be a better alternative. So instead of us always contributing, we can also look for the other projects that have already solved this problem and leverage them. So again, Mimir architecture-wise, it's similar to that of Thanos, but it is much more optimized, both on the reads and writes. The writes write into a distributor, which writes the data to an ingester, which is a TSDB in this case. And then for the long-term storage, it writes the data to an S3 bucket, right? And for the reads, it queries the query front end, and it can also have a scheduler that can hold the data for the queries and for the queries that we are punching in by splitting the queries into smaller chunks. And the querier would pick it up and respond back to it and so on. That's where the optimization was done. So it kind of improved the overall read performance, right? So with Mimir, the same architecture, what we have done is we have updated it to leverage a hotel collector instead of using Prometheus, because hotel collector is becoming, OpenTelemetry in general is becoming a standard in the observability space. And then we are writing data into the Mimir. And for all these various use cases, because Thanos was not scaling, we had to write into individual Thanos receive instances. But now we have just pointed it to Mimir because Mimir is able to scale. So this is a read performance on Mimir. As you can see, we are not seeing those kind of issues anymore, and our latencies are in the order of milliseconds and less than 5 seconds, and for a lot of heavy queries in the order of 12 hours of data that we are retrieving, right? The other issue I wanted to talk about is, as we are using Open Telemetry Collector, the way it works basically is it has multiple components like hotel collector pods as well as target allocator. So target allocator essentially looks for objects like service monitors to identify the targets that it has to scrape, for example, the pods, and then distributes that to the hotel collectors, right? And hotel collectors essentially have a process called Prometheus receiver that receives this data from these targets and ships them to the exporters. As you can see in the diagonal diagram in the below, there are receivers and there are exporters. In between, we can write some processes to manipulate the data that we are getting, or compress it, or uh, rewrite the data into a different format and whatnot, right? So there are various things that are available in the hotel collector. This extension is what we were looking for as we are updating our design. But some of the challenges that we faced with this is that hotel collector, when it receives data, it receives in the text format, which is in the Prometheus format. But the Prometheus receiver part of the hotel collector processor, it writes the data back into the exporter in the Prometheus. It translates the data from Prometheus format into OTel format, and then writes the data into exporter, and that exporter consumes the data in the OTel format, and then it translates back into Prometheus format, which is a lot of overhead, and it is taking up a lot of memory. The other thing that we have also seen is that the Prometheus exporter here, it does not have relabel configurations. So the right relabel configurations, as you can see in the bottom configurations. So the relabels here essentially help us to reduce the cardinality when we write into different XML systems. Either we can drop certain label that is of high cardinality when we write into a target time series database, or we can update it with standard labels and so on. That configuration option was not even there in the Prometheus exporter as we started exploring. So we had to make those changes and leverage it in our systems to have this. Once we roll out some of these changes, we will also contribute back into open source. So yeah, as we start leveraging and consuming more and more open source projects, we identify a lot of these challenges, and we can contribute back and get the feedback from the community and so on, right? Not only contributing, but also identifying new patterns and sharing with the community is also a contribution to the open source, is what I think. So anything that you have consumed and you have modified it to a specific pattern that worked in your use case, don't hesitate to share in the forums, like community talks or open source meetings or talks like this. It's always welcome, and somebody might learn from what you have done, right? So the one that I talked about is only on one dimension so far on metrics, but there are various other pillars of observability that we talked about. At Intuit, we are also doing a lot of open source contributions into various other projects. For example, we are consuming Apache Iceberg for logs by using Trino as a search engine, and leveraging raw data with S3 buckets and so on. And we are using Fluentbit to ship the data into the target S3 buckets and Splunk and so on, right? And then in tracing, we are again leveraging open telemetry to consume the traces from the applications, and at the same time, we are storing them in Apache Parquet format, and we are using ClickHouse to search the data. Again, in profiling, we've just started our journey. There are various tools in open source for profiling, like Pyroscope, Parka, and recently OpenTelemetry introduced eBPF profiler, so we are exploring those things. So yeah, just wanted to call out, there are any area you pick in, there are probably a lot of open source projects available. You can pick them and start using them, and you identify a gap, you can go ahead and contribute. So that can help a lot of others, right? So that's the spirit of open source. Just wanted to call out. That's all I have for the content today. Any questions?
Profiles. On when we talk of profile, sorry. When we talk of profile, the aspect of where the event is generating, that is also important. So anything that we are doing on that direction.
So where the event is generating in the sense, the source of the event,
Yes,
etc.
yes.
Yeah. So we are connecting all the way to the lowest level as possible to fetch the data. That is at the container level is what we are going to, or the process level is where we are getting the data from and so on. But again, based on the current available resources, these are the places where we are able to fetch the data. And at the same time, there are emitters such as logs, metrics, and other things that represent this internal state of the system is what we are translating into these outputs and leveraging it. But those are the current dimensions that we are looking at. But are you looking for anything more specific?
Yeah, because since we are working on the AIOps side also, so
Right.
topology is very important to understand
Right.
to get into detail of what's happening to a system. For example, if I am saying seeing a matrix in a silo, it may not make sense. Instead, if I see from where it is coming and what are the surroundings behind it.
Yeah.
So that is very important aspect.
That is where tracing is helping us. Like it is able to connect the dots and identify from which particular system a particular issue is happening. We are able to navigate that through the trace ID propagation and whatnot, and we can extract metrics from the traces and so on. So
Dependency graph also.
Yeah, okay.
We have about 15 minutes there.
okay,
Can I also have Ashwini?
sure. Yeah.
I mean, you can also. Ashwini, can you please join? We have 15 minutes for Q&A. We can talk about the dependency graph.
I think one point that I would like to add, right? The context, for the most part, we're relying on tracing for capturing the context. That hasn't fully matured, to be really honest, because most of the people tend to use whatever comes by default with the instrumentation. And that thinking has to evolve, right? It cannot be forced upon by an observability team or even dictated by an observability team, right? It depends on what data you want to capture, etc., right? And how you want to use that data. Specifically, as it comes to profiling, there is you can think of profiles as a summary of all the traces that have happened probably in the profiling window, right? So what we are looking at primarily is the specific uh, traces that may have been processed or requests that have or spans that may have been emitted in the profiling window. We are trying to capture examples of that, keep them as exemplars. And when I looked side by side, like, well, this profile was happening, these were the spans that happened. And coupled with techniques like tail sampling, etc., you could identify, you could pick the specific requests that exhibited any kind of unusual or interesting attributes, right?
Yeah. Yep. Thank you.
Cool.
So you have moved from Prometheus to Mimir for. So what was the kind of volume that you were?
With Mimir, we are able to scale all the way up to 300 million metrics.
Okay. So that was the requirement, and then Prometheus was not able to handle that.
Yeah, Prometheus, because it's a not a horizontally scalable system, it cannot handle too much load. It can only scale vertically up to certain limit. The more you scale it vertically, the longer it takes whenever you do an upgrade and restart happens for it to replay the write-ahead logs and so on. So it's better we limit the size of Prometheus or such kind of time series database and scale horizontally for the flexibility and upgrades and other things that we keep doing on a regular basis on our systems for maintenance.
Okay, and also you have mentioned a contribution on S3 plus Spark. So
We are consuming that, and you want to add?
So the goal was to use, right? I mean, one of the ideas is that do we really need to ingest all the observability data into any specialized stores? Can we not just leverage the fundamental, a basic object store and run whatever queries, right? Because this is write once and very rarely read, right? I mean, you'll be very lucky if you, I mean, well, I wouldn't call it lucky. It'll be very unfortunate to read more than 1% of the data that you have captured in observability, right? The less you look at it, the better your system is behaving. So um, that's the insight, which means that you don't want to spend too much money on ingesting the data into specialized stores. And if you look at the industry itself, especially the storage aspect of it, what at least I realized is that the concept of database itself is being sliced into multiple horizontal layers, and at each layer there is an innovation happening. Each and every company is picking apart that particular layer and putting out some specialized things, and there is also this realization that all these layers have to work together, and these innovations cannot be like these islands that somebody has to pick up and collect. So that's the fundamental driver, right? That's the thinking that we had. So based on that, we wanted to see Iceberg as a potential table format. We haven't done much yet, but we hope to sort of use it as a primary thing for majority of the this one, because when I compare it with Hive and our experience with Hive, I see some really good things in Iceberg. There are gaps, but I think those gaps can be fixed and addressed. That's the driver for Iceberg, and Spark is there just as a interim. Uh, we wanted to quickly get some results out of Iceberg plus Trino. So we wanted to use Spark as an ingestion engine, but I think it's not terribly difficult to write your own Java client. Right. Okay. So expanding on the storage, right? So we have the raw data for which object store will be is ideal, at least. I mean, at least that's what I think, the current thinking. But you could also argue that there are these aggregations that tend to happen. There are these summaries that, for example, traces by itself don't add any value. There are summaries that you can leverage, and you can summarize it at many levels, right? It doesn't have to be the entire trace. It can be like this subset of trace that you want to look at, specific spans, hotspots, etc. So for these analysis, it produces a lot of metrics, and there is also this problem of cardinality that you will run into. The question about the context is really pointing in the direction, because the more context you have, the more tags you have, the harder it is to store them. And some of the stores we talked about, right? Now, Mimir is probably one store where there is a promise of high cardinality support, but the other stores that we are using and we have used in the past, they're very terrible at handling cardinality. And if you think about it, that data, that problem is actually an analytics problem, right? So we need an analytics store. So that's the driver for, we started looking at ClickHouse as an analytics store.
okay. So, but did ClickHouse help you in terms of search? Because generally it's a bulk write, and then so you also mentioned the point that it helped in you.
So search is a different problem.
Okay.
What I'm talking about is you want to mine the data to gather some insights. That is where I see ClickHouse coming into picture. As far as search is concerned, you have to think about these attributes slightly differently. Maybe you can, the ClickHouse could be the store for all these attributes as well. But when you're searching, at least in traces or even logs, what you're really searching for is the specific set of tags that exhibit the problem, that point towards the problem, right? So definitely there is some work that we need to do there. We have started pushing all the tags and creating some sort of a tag store idea, the idea of a tag store so that you can mine the data. But I think there is a lot more that can be done, especially around uh, identifying what tags are exhibiting highly cardinal, what tags correlate with successful requests, what tags correlate with unsuccessful requests, and how does this information can be overlaid on top of, let's say, dependency graph and whatnot, and see what code path leads to this, let's say, high latency requests or unsuccessful requests, etc. That's just one example.
Thank you.
But as a standard, what we are looking at is S3 will be our raw data store. We saw and learned that writing into these commercial products where they charge for ingestion is not very cost effective. So if we can leverage open source there and start using S3 as our store and build on top of it, it would be much more cost effective.
Have any open source tool or stack for the anomaly detection and the classification?
Yeah, we have NumaFlow and NumaLogic for that.
Yeah, I mean, anomaly detection, I think there is a lot of work that has already happened in the industry. I don't think we need to solve the problem from scratch, to be honest. I think leveraging existing models, getting your data pipelines and the inference pipelines along with training, etc., correct, will help you. The bigger challenge will be in terms of, how do we know that it is actually working?
So at the storage layer, are we using the tiers also? Because as we're using S3, so are we using the tiers, data, dividing the data into tiers for storing? Because in the long term, it is a very...
Yeah, I mean, tiering is definitely a part of the problem. Because, for example, let's say, I think maybe Ravi will probably get into more detail, but golden signals are, the reason that we call them golden signals is because they are tier one, right? And then there are these additional metrics that people configure on their services, scraped and whatnot, that are treated as tier two, right? And we are moving towards an architecture where we are saying that all the tier one data has as less number of dependencies as possible, less number of hops, less number of dependencies, alerts and everything. They get generated closer to the source as early as possible, and we start, so correlating the data with other alerts that may subsequently fire. So that's the direction we are moving.
So any thought on providing a search facility on the tier 2 and tier 3 data also?
I mean, tier 2, tier 3 data, it totally depends on what you want to call as it. It's just another search problem, right? The tier 2 tiering is just an abstraction that you are bringing in. It's not necessarily a requirement for observability to work, right? You don't want to spend too much money, so that's why you label that as tier
Because
2.
many of the compliance also comes into picture there, so you need to have that data stored for some time and then retrieve for, especially when we are going to the ML side of things, you want to retrieve it back for your training.
There is a long-term storage that we do have that requirement. We have to store some data for 7 months, 7 years, some data for like 30 days, 90 days, etc. There is an opportunity there. I will not deny that, because right now, at least in case of logs, all this data is shoved into one single store. Uh, there is an opportunity.
But at the same time, we also have opportunities to roll up this data for the tier 2, tier 3, so that, which is a standard practice that has been adopted by a lot of these companies.
So one of the problem that we see is that when with this hot, warm, and cold kind of tiers that we talk of, especially for the machine learning modeling, as outlier detection or anomaly detection that we work on, we may want to utilize that data. And typically, when we move those into cold or in, I'll say, cold storage, and retrieving itself is a big challenge for the model to work.
Yeah, we have this multi-tenancy option in these tools. For example, the AI ML data that we want for training and other things, you don't need all the raw data for it. You are looking for specific set of metrics or some specific set of traces or other things, right? So those can be stored in a different tenant. You can have different policies for it, right? That's how you kind of segregate and solve the cost problem instead of putting everything in the same bucket and looking and searching in the same thing.
Sure. Thank you.
All right, I think we are up on the time. We can take more questions offline.
Awesome. Thanks, Ravi, for this insightful talk. I'll request Kalyan to hand over some speaker swags for Ravi and Ashwini.